Hey there and welcome. So, think about all the powerful technology around us. I mean, everything from massive industrial plants to the power tools sitting in your garage. What's the one thing that stands between a totally normal day and a catastrophic failure? It's not luck, that's for sure. It's a really deliberate, multi-layered system of prevention. And today, we're going to break down exactly how that works.
Okay, so this might look like just some dry, boring warning you'd find buried in an industrial manual, right? But it's so much more than that. It's a stark reminder of what's really at stake here. In any complex system, failure is this constant pressure that you have to actively, constantly manage. So the real question isn't if things are going to break, it's how do we build systems that are robust enough to handle it when they do? Because it's inevitable.
So, where does failure even begin? You might think it's some big, dramatic event. But honestly, it's often not with a bang. It's more like a whisper, you know, a tiny little problem that we just learn to ignore. We're about to dive into a really dangerous psychological trap that can completely undermine even the best designed systems out there. And here it is. This concept is so important. It's called the normalization of deviance. Now, this term actually came out of the investigation into the Space Shuttle Challenger disaster. And it's this idea of a slow creep, a gradual acceptance of lower and lower standards. A small issue pops up, right? But nothing catastrophic happens, yet. So that little issue, it just becomes the new baseline, the new normal. And that is an absolutely critical human factor that we have to constantly fight against. This analogy is just perfect. Think about it. You've got a car, and there's a hole in the muffler. At first, it's super loud, and it's a clear sign that something is wrong. But instead of fixing it, what do? You just turn up the radio. Then the muffler gets even louder, so you turn up the radio even more. See what's happening? You've just normalized the problem. You've accepted this deviation as the new normal. And you keep doing it until, you get pulled over. Or maybe a friend gets in the car and is like, what on earth is that noise? Okay, so if that's the problem, how in the world do we fight this tendency to just turn up the radio? Well, the very first step is to actively go looking for trouble before it has a chance to become the new normal. And that brings us to our first line of defense, having a really structured way to maintain the physical integrity of our systems. And this is where we get into the nuts and bolts of it. The core practice here is called mechanical integrity. And listen, this isn't just about fixing things when they break. No. It's a whole program designed to make sure they don't break in the first place. I mean, it covers the whole shebang, from the moment a piece of equipment is designed to how it's installed to its daily operation and all the routine maintenance. And this idea has two layers, which is really smart. Think of it like this. Your primary defense is the thing itself. The actual pipe that's holding the hazardous chemical or the tank that's containing all that pressure. Mechanical integrity is all about keeping that first barrier super strong. But what if it fails? Well, that's when your secondary defense has to kick in. We're talking about the alarms, the ventilation systems, the emergency shutdowns. A really good safety program takes both of these layers just as seriously. And look, this isn't some vague idea of just, checking on things every once in a while. It's a super disciplined process, and it's built on a relentless rhythm. This schedule you see here, going from daily checks all the way up to 5-year overhauls, it creates this consistent baseline. It's like the system's heartbeat, and it's designed for one specific reason, to stop that slow creep of normalizing deviance right in its tracks. Okay, let's make this really concrete. What you're looking at is a real-world test for an emergency shower. And notice, it's not just pull a handle and see if water comes out. Nope, it's a quantitative test. It asks a specific question. Does it deliver at least 2 gallons of water in exactly 6 seconds? It's that level of detail that ensures your secondary defense, that shower, is actually going to work when you desperately need it most. It's a perfect example of what active, rigorous prevention looks like. Okay, so you've got a schedule for inspections, you've got a detailed test procedure. That's great. But how do you make absolutely sure that everyone, and I mean everyone, performs that test the exact same way every single time? Well, that's where we have to move from the physical equipment into the world of clear, written instructions. And that's where the standard operating procedure, or SOP, comes into play. You can really think of it as the bedrock of consistency. It's basically the entire organization coming to an agreement on the single best, right way to do a task. It's all about empowering every single worker to do their job perfectly and, most importantly, safely. But here's the thing. Not all tasks are created equal, right? For a really simple, repetitive job, a basic numbered list is totally fine. But when things start to get complicated, the format of that SOP has to evolve right along with the task. And this is so important because picking the wrong format can actually be just as dangerous as having no procedure in the first place. So that leads to a really crucial question. What happens when a task isn't just a simple list of steps? What if a decision needs to be made? What if a technician sees a pressure reading that's a little weird? The procedure can't just be a list of actions. It has to guide them through how to think and how to decide. And that is the incredible power of a flowchart. It literally visualizes the decision points, all those what-if scenarios. So instead of forcing someone to guess what to do in a moment of stress or uncertainty, it just hands them a clear, pre-planned map that leads them directly to the right course of action. It's brilliant. All right, so we've got our physical checks, we've got our written procedures. Let's zoom out one more level. Let's look at the entire organization's philosophy. How does a company build its whole approach to quality and safety from the ground up? Well, there are two major frameworks that really shape how this is done. So what you're seeing here is a comparison of two huge quality frameworks, and the key difference really boils down to their core philosophy. On one hand, you've got GMP, or Good Manufacturing Practices. This is all about compliance. It's mandatory, it's legally enforced in industries like food and pharmaceuticals, and it's there to protect public health. Bottom line, you do it because you have to. On the other hand, you have ISO 9001. This is all about excellence. It's a totally voluntary system that any company can adopt to get more efficient and make their customers happier. It's something you do because you want to be better. Big difference. Okay, so we've built the system, we've written the rules, we've set up the quality framework. It feels like we've covered everything, right? But there's one final, absolutely critical link in the safety chain: communicating risk directly to the person who is actually using the product, the human interface. And this leads to a question that is way more complex and high stakes than you might think. Where should a safety warning actually go? Do you put it directly on the product itself, or do you bury it somewhere in the owner's manual? If you put every single warning on the product, you get what's called label clutter, and people just stop reading any of them. But if you only put it in the manual, well, you risk it never being seen at all. It's a tough one. So how do you decide? Well, there's a really smart way to think about it, a kind of balancing act based on three key questions. First, how bad is the hazard? Are we talking a minor scrape or something life-threatening? Second, does the user need this information every single time they use the product? And third, is it even physically possible to put a label there that will last? The answers to those questions really point you toward the most reasonable and effective place for that warning. And here is a fantastic real-world example of that balancing act in action. A court actually looked at this exact issue and found that Black & Decker was being totally reasonable when they put this simple, direct warning right on the drill itself. It's perfect. It alerts you to the potential for danger, and then it points you to the owner's manual for all the details. It avoids that label clutter, but it still absolutely fulfills the company's duty to warn you. Okay, so we have inspections, we have procedures, we have these big quality systems, and we have warnings for the user. We've got all these individual pieces. But the big question is, how do you tie it all together? How do you go from just having a collection of rules on a shelf to creating a living, breathing culture of safety? And really, this is the ultimate goal. If you take away one thing, let it be this. The point of all this documentation, all these procedures, it is not just to have binders full of paper to make an auditor happy. The real goal, the true goal, is to build an ingrained culture where every single person feels a sense of ownership and personal responsibility for preventing failure. The rules, they're just the tools you use to build that mindset. So what's with this number, 172? Well, think about it like this. A basic safety standard might say you have to replace all your pressure relief valves every 5 years. Period. That's a simple, time-based rule. But a smarter, more advanced approach is to test them. And if the tests show the valves are still perfectly good, you can safely extend that replacement to maybe 10 years. Over a 20-year period at one facility, taking that smarter approach meant they avoided replacing 172 perfectly good working valves. It's about being smart and effective, not just blindly compliant. So at the end of the day, we've seen all the different layers of defense that we build, right? The physical checks, the written rules, the big quality systems. But all of it, every single piece, relies on one final human element: our refusal to start normalizing the small problems. So the real question I want to leave you with isn't just about industrial plants or big factories. It's about our own lives. Which loud mufflers are you ignoring right now? And what are you doing to just turn up the radio instead of actually fixing the problem?